So we have this question which comes with a formula. Surface area of a cone with radius r. I don't know if you remember that formula was something that you did in grade 10 pre-calculus. On your formula sheet, figured out all sorts of surface areas. Okay? A cone has a surface area of 300 centimeters squared and a slant height of 15 centimeters. What is the radius? So we want to solve for r, but we're told some stuff. We're told the area is 300, so we can plug that in. We're told that the slant height is 15, so we can plug that in. And we get this equation. And this equation, they would have never asked you this question in grade 10 because you didn't have the ability to solve equations that were quadratic, because this one has an r squared. Now that we're in grade 11 and we have the quadratic formula, we can solve this, but first of all, we have to set it up so it looks like how we're used to a quadratic formula. Remember, our quadratic formula works if we can get it in this form, and then we can just plug things into the formula, which looks like that. But right now, our equation doesn't look like that, okay? This equation has an x squared and an x. Our equation, because we're solving for r, has an r squared and an r. So we want to rearrange our equation to look like this. Well, the term with the x squared is first, so I'm going to rearrange my equation by, I'm going to move the 300. I'm going to make one side equal to 0. That's easiest by moving the 300 over. My term with the r squared is pi r squared. My term with the r would be plus 15 times pi, 15 pi times r. And then I move the 300 over minus 300. So once again, I notice there's my r, there's my a squared. That means this will be my a value, pi. 15 pi would be my b value. And negative 300 would be my c value. Not very much fun to complete the square on this one. Okay? Quadratic formula, though, doesn't matter what the numbers look like, you can solve for them. So, we say r equals, because we have r instead of x, negative b, so it'll be negative 15 pi plus or minus b squared, so that would be, I'll put it in brackets, 15 pi squared minus 4 times a, which is pi, times c, which is negative 300, over 2a. And this is where it's nice if you have a calculator that lets you use fractions, that lets you type in exactly what you see. Because a question like this one, you wouldn't have to simplify how we've simplified other ones with just numbers. This one's looking for an answer as a decimal. It even says to the nearest hundredth. That's a hint that you can just use your calculator to find the answer. So now that I've typed it into my formula, I pull out my calculator. If you have a calculator that lets you do fractions, I would highly recommend using that option right now. So on my calculator, I can get a fraction like this, and then I can just type in negative 115 pi. I'll do one with the plus sign, plus square root of bracket 15 pi bracket squared minus, I might just put a plus sign. Sometimes I do a little bit of mental math. Can you see minus times a minus is going to be plus? So we're going to get 4 times pi times 300. I used the times button instead of brackets. It would have worked on my calculator to put it in brackets as well. Divided by 2 pi. So we want to be able to use our calculator to get answers. Do we know how to type things into our calculator? If you have the fraction button, makes things really nice, because we get 4.818 to the nearest hundredth would be 4.82. And then we also have to retype this in and instead of the plus sign, do a subtract sign. Because in the formula there's the plus or minus. When you actually type it out, you have to do those separately. Once with the plus sign, once with the minus sign. The graphing calculators, for those of you who have a graphing calculator wondering how I retyped it so fast, if you push the second button and the enter button, it takes an entry that you previously typed and just retypes it for you. So it's a little trick that can help make things go faster. If I push enter on this one, I get negative 19.82. Both of those answers are mathematically correct, but this answer makes no sense in the context. You can't have a radius that's negative. That's not a thing. It just doesn't exist. It's like when you're finding the average number of people and you're like, oh, there was 7.2 people there that day. No. You can't have 0.2 of a person. Well, you don't want to have 0.2 of a person. Your imagination goes in bad places if you think that way. So this answer doesn't make sense. The only one that does make sense is 4.82. Again, I am answering an actual question. I'm looking at my units. I have centimeters squared and centimeters, so I will need to make sure that I've rounded correctly, I've included my units, and that's again why we go back and reread a question at the end to make sure that we've got all of our details there. Questions for practice on this one are 14, 15, and 16.